Hello, my name is Jaime Reina. I am 16 years old. I am from Humble, Texas. I am currently taking Math 1203 with Professor James Basher online at Laterno. Here is my video presenting how to do my math problem.
Today we will solve an objective function constraint problem. We will find the maximum and minimum values for x and y. We shall find the answer by graphing the equation and working through the problem one step at a time. Our problem here is z equals x plus 6y. X is greater than or equal to 0. Y is greater than or equal to 0. 2x plus y is less than or equal to 10. X minus 2y is greater than or equal to minus 10. The first line in the equation, z equals x plus 6y, is the equation we will need to find both the maximum and minimum values for x and y. In this slide, we are graphing the equation 2x plus y is less than or equal to 10. You can see the equation on the screen, so we do not get confused with different graphing equations that will be in the graph. We colored this function green. The next thing we will graph is x minus 2y is greater than or equal to minus 10. We colored this function purple and wrote down the equation on the screen as well. In this slide, we can see both previous functions in the same graph. Both are colored the same and have the function written in the same color. Judging by just these two functions, our common area can be in all four quadrants. We need more information to determine which quadrant our common area will be in. Here we see x is greater than or equal to 0 in the graph. We colored this function red along with the label next to it. Next, we can see our last three functions together. With the x is greater than or equal to 0 function, we can say that our common area must be in either quadrant number 4 or 1. Let us graph our last function to narrow it down to just one quadrant, and hopefully it will give us one answer. This slide shows y is greater than or equal to 0. Judging by just this function alone, we can say that our common area would be either in quadrant number 1 or 2. Here is our four functions together in one graph. Each function has its own color and its own value next to it in the same color. It may just seem as random mess to some of y'all, but here we can see that our common area is in quadrant number 1. Our next step is to find all four x and y values and insert them into the equation that will tell us our maximum and minimum values for x and y. The first point we can see is 2, 6, with our x value being 2 and our y value being 6. The next point is located at 0, 5, our x value being 0 and our y value being 5. The second to last point is at the origin. The origin is where the x and y lines intersect. This is at point 0, 0, where both the x and y values are at 0. Our last point is at 5, 0, our x value being 5 and our y value 0. The last step is to find the maximum and minimum values for x and y. In order to do so, we had to insert our x and y values into the equation z equals x plus 6y. Our first point was at 2, 6. When we insert it into our equation, we get z equals 2 plus 6 times 6. Since we do not have parentheses or exponents, we start with multiplication based on PEMDAS. So 6 times 6 is equal to 36. Then we add 2 and you get 38. For our first point, we get z equals 38. Our next point was at 0, 5. We get z equals 0 plus 6 times 5. We start with 6 times 5 is equal to 30. Add 0. For our second point, we get z equals 30. Our second to last point was at 0, 0. We get z equals 0 plus 6 times 0. We start with 6 times 0 is equal to 0. Add 0 and get 0. Our last point was at 5, 0. We get z equals 5 plus 6 times 0. We start with 6 times 0 equals 0. Add 5 and get 5. Our maximum value for x and y occurred at point 2, 6, in which we got z equals 38. Our minimum value for x and y occurred at point 0, 0, or the origin, where we got z equals 0. Therefore, our maximum point for x and y is 2, 6, and our minimum point is at 0, 0. This concludes this video.